Artificial intelligence is not just a technology anymore, it's a decision maker. It recommends who gets a loan, predicts who might default, and even diagnoses diseases before doctors do. But with great capabilities comes great exposure. So, the question for every business, regulator, and technologist is how do we manage AI risk with the same discipline we manage financial or operational risk? That's where AI risk management cycle comes in. A structured, repeatable, auditable process that turns abstract fears into measurable, governable actions. The purpose of this life cycle is simple: to make AI trustworthy, traceable, and testable. It gives organizations a consistent way to identify, assess, mitigate, monitor, and govern the unique risks that AI system introduces. Think of it as the safety operating system for the age of algorithms, thus ensuring AI remains beneficial to humans, compliant with laws, and aligned with organizational values. Without a life cycle, AI risk becomes reactive. Problems are discovered after the deployment, often in the headlines. With a life cycle, risks becomes proactive. Issues are anticipated, measured, and mitigated before they can cause harm. The AI risk management life cycle isn't theoretical, it is practical. Five clear, interconnected phases. When phase one is about identifying, that is, what AI systems exist, where can they cause harm. Phase two is assessing, that is, how serious are those risks, technically, ethically, and operationally. Phase 3 is mitigate. That is, what controls and safeguards do we implement? Phase 4 is monitor. That is, how do we continuously detect drift, biases, or misuse? Phase 5 is govern. Who owns accountability and ensures long term assurance? These five phases form a continuous loop, not a straight line, a loop. Because in AI, risk doesn't end at deployment, it evolves with every data update, every retrain, every user interactions. In this first phase, the goal is visibility. You can't manage what you don't know exists. Organizations build an AI use case inventory, listing every systems using machine learning, using natural language processing, or automation. Each use case is profiled with fields like purpose, data source, stakeholders, and potential harms. Then comes risk tiering, classifying each systems as low or a medium or a high risk based on its impact on people, privacy, or financial exposure. For example, a chatbot answering an FAQ might be a low risk, but an AI deciding loans approval or diagnosing medical condition are just high risk. This phase creates your map of exposure, the foundation for everything that follows. Once you know your AI landscape, the next step is to assess the risk quantitatively and qualitatively. Here we measure across six dimensions: biases and fairness, explainability, robustness, privacy, security, and compliance. Each dimension has measurable indicators. Fairness might use statistical parity difference or disparate impact ratio. Robustness may use accuracy degradation under drift or adversarial resistance test. Privacy might track the PII exposure or differential privacy metrics. The output of this phase is a risk scorecard, a radar view of where your AI systems are strong and where they are fragile. The purpose here is not to stop AI, it is to understand AI. Because what you can measure, you can manage. Assessment reveals weaknesses. Mitigation builds defense. This is where risk turns into action. We group controls into key themes: data governance, ensuring data quality, lineage, and consents. Model design helps in embedding fairness, validation, and explainability. Privacy by design, it's protecting identity and limiting re identification risk. Security controls, it's about guarding against adversarial attack or misuse. Human in the loop, it is ensuring humans can review, override, and correct the AI outcomes. Policy and legal controls, it aligns AI behavior with regulatory frameworks. For each theme, we track KPIs, model validation pass rates, drift response time, privacy incident frequency, override rates. In short, mitigation is about turning governance from paper to practice. It's where responsible AI stops being a slogan and becomes a system. Now, once models are live, governance doesn't end, it evolves. This is where we monitor AI in the wild because real world data, user behavior, and adversarial conditions constantly shift. Here we monitor 7 layers. Performance, wherein we check is accuracy stable, are business KPIs still met? Drift is has the data or context changed over time? We monitor fairness, wherein are new biases emerging in production? We monitor explainability. Are explanation still coherent and stable? We monitor transparency, where we check are model cards, logs, and approvals up to date? We monitor security, where we check any unauthorized access, or are there any adversarial probes, or are there any tampering. That's security aspect. And then we monitor abuse and incident responses, wherein we check are users misusing the AI or are incidents resolved quickly. This is where AI becomes observable. Like an airplane where sensories and the telemetries are looked at, ensuring safety mid flight. The final phase is govern. This is where AI risk management becomes institutional. Governance gives rhythm and hierarchy to everything we discussed. It defines who decides, who validates, who assures, who trains, and who discloses. At the top sits the AI risk committees, wherein setting risk appetite, approving high risk systems quarterly. The independent validation team acts as a second line, verifying model integrity and bias mitigation. The AI audit function provides independent assurance annually and aligning to maybe ISO 42001. The training and awareness programs embeds responsible AI into the culture of the organization. And external disclosure are done through annual AI governance report, which helps to demonstrate transparency to regulators and public. Now, governance is not about control for the sake of control. It's about clarity. It transforms AI risk from a specialist concern into a boardroom agenda. Now, how do you know where your organization stands? That's where the AI risk maturity model comes in. It typically evolves across 5 levels. Ad hoc, that the AI risk identified after an issue has occurred. That's your first level of ad hoc. Second is defined, where the policy do exist but are inconsistently applied. The third is integrated, wherein risk lifecycle is embedded in AI development, whether it is ML ops or compliance ops. The next is assured level, where it is continuously monitoring and audit ready evidences are available at any given point of time. That's assured. And finally, we reach a stage of being institutionalized, where risk management is a culture. Ethical AI are built by design. So, maturity isn't about perfection. It is not about perfection. It's about progress. Each cycle of improvement strengthens the trust, resilience, and compliance. The AI risk lifecycle doesn't exist in isolation. It's built on the foundation of international frameworks. The NIST AI risk management framework gives the rhythm of govern, map, measure, or manage. The ISO 42001 defines the structure, the AI management system that makes governance auditable. That's ISO 42001. The ISO 23894 connects to traditional risk methods, linking AI risk to the enterprise risk register. The EU AI Act defines the legal boundaries, especially for high risk systems, requiring conformity assessment and transparency. And the SR 117 from the banking world deepens the rigors, reinforcing independent validation and model risk governance. Together, they make AI governance both strategic and enforceable. The life cycle is the how. Frameworks are the why and the what. And when they click together, assurance becomes continuous, not episodic. To summarize, the AI risk management lifecycle gives structure to uncertainty. It transforms complexity into cadence and innovation into trust. It's not about slowing down AI, it's about steering its safety. In the coming years, regulators won't just ask if your AI is powerful, they'll ask if it is accountable. Boards won't ask if you have models, they'll ask if you have governance. And customers won't ask how smart your AI is, they'll ask if it is fair, secure, and human centered. That's the power of life cycle. It turns responsible AI from philosophy into engineering and from compliance into confidence. Welcome. Welcome to the era of AI risk management where we no longer chase risk, we orchestrate it. In the end, managing AI risk isn't about algorithm, it's about alignment. The life cycle simply gives us the discipline to stay aligned with people, with purpose, and with principles. This is your host, Savit Vittal Salian. Let's dive into the chapter 4 of this series on AI risk. We will look at the AI risk management life cycle in this video. So, welcome. Let's start the journey. This is your host, Savit Vittal Salian. Namaskar. The overall agenda for this series, as shown, for this part, we will be focusing on the AI risk management life cycle. The specific agenda for this video is as shown. Let's look at the cycle. Starts with identify, then assess, mitigate, monitor, and govern. Part of a typical risk management life cycle. Now we look at it through an AI lens. The purpose. The framework tells us what to do. The life cycle explains how it happens in practice. Looping risk discovery, evaluation, and control across every AI system's life. Each phase must leave evidence artifact that flows seamlessly into the next, forming an audit ready risk thread. Let's try to understand it deeper. The life cycle has these 5 phases: identify, assess, mitigate, monitor, and govern. The key delivery in identifies for from an AI perspective is AI use case inventory, the harm map, and creating a data lineage. The core question in this should be what can go wrong? The owner of this would be the product owner or the AI risk owner, or and. At an assess phase, the question that we should ask is how bad and how likely are the risk. The key deliverables here are risk scorecard, bias and robustness metrics. That's what has to be delivered at this phase. The owner for this would be the validator or the model governance team. The next is the mitigate phase. The question one should think about it: what controls would reduce the exposure of the risk and its impact? The expected delivery is getting a mitigation plan, getting a control registry in place, and testing the evidences. The ownership would be with engineering and the risk team for this specific phase. The next phase is monitoring. The question one should ask is it behaving safely over time? The expected delivery at this stage is having a drift dashboard, alert mechanisms, and do we have a periodic re-evaluation in place? The owner in this case would be the MLOps team or the operational risk team. The last phase is govern. The question in this we should be asking is, are we learning and are we accountable for what we have built, or who are? The delivery that is expected are the reports, the exception reports, and the board's attestation that is required to be in place. The owner in this case is the CRO or the AI risk committee. Phase 1: identify. The objective of this phase is to reveal and describe risks before code or data is locked. The core action in this phase is inventorying every AI systems, which includes its purpose, the data used, what was the context of the decision, what's the autonomy level, and what are the regulatory classifications. The second is mapping potential harms using a stakeholder lens. The stakeholder could be individual, organizational, or societal. The third is tracing data lineage. This is a place where you look at the lineage from its source perspective, consent perspective, representativeness, sensitivity, and geographic flow. The next is flagging models criticality, which means we look at the business impact in combination to its autonomy and regulatory exposure. The idea is to create the AI use case profile. Let's try to understand this deeper. Now, what's use case? The first one is name or identification. Example, credit underwriting model. The second is what's the objective, primarily from a business perspective. Now, in this case, we'll say automated risk scoring. That's the objective of this use case. Then we say what is the model type? Could be gradient boosted tree or any combination. We look at further examples of this as we move forward. Then we define the data source. So in this case, the data source could be your internal loan history or a credit bureau data. Then we look at what's the tier of the risk. Could be high due to because of regulated financial decisions are taken in this model. The next important is who are the affected stakeholders. Affected stakeholders could be customers, credit operations, regulators, and so on and so forth. Then we move on. What are the potential harm this model can make? Could be, is there a potential for discrimination or unexplainable denial? And finally, control references. So this control references could be references from your policy or from a framework. So that's something that you can put up. Now, primarily in control references, you can map onto the framework that you as an organization have agreed to implement in your place. Let's take a few more examples so that we get clarity. The first one is from a BFSI sector. This is about credit scoring model. So use case, the name would be credit worthiness scoring engine. Well, you can name it according to your taxonomy. You would have your own naming convention. That is something that you can choose. Then we look at from a business objective. What's the objective? The objective would be to automate loan eligibility decisions, to improve turnaround time and reduce manual underwriting costs. So basically, this is a description of the whole system or the case profile. What this is all about. The next is model type. So we said gradient boosted decision tree. This is an example, do note. You can have your own model type. You can name it as you want to, which is relevant for your space. Then we go on for data source. In this case, it's internal banking transaction history, bureau credit report, demographic data, or customer income statement. The next is tier of the risk. If it is regulated financial decisions, it constitute potential discrimination is a possibility, and there are compliance implications, it would generally be at a high. So that's your risk tier. Stakeholders could be retail loan applicants, credit analysts, compliance team, or regulators. Harm could be a bias outcome across genders or region, or unfair loan denial, or data privacy breaches, or model drift causing misclassification. As you mentioned, your control references could be from AIF 360, or it could be from SHAP, or it could be SR 11, or it could be ISO 42001. You can have a reference there mapped on. Let's go with few more examples. The next is from healthcare. This is the use cases here is radiology image classifier, say lung scan example. So this supports a radiologist by detecting his early signs of pneumonia or tumor to speed up diagnosis. So that's your objective. You would have your model type, could be neural network or deep learning image classifier and so on. Data source would be hospital packs, archives, patient image records, or curated labeled medical data sets. Risk definitely is high as it is involving medical part of the process and people are directly impacted. Stakeholders could be patients, radiologists, healthcare provider, regulatory compliance teams. Harm, false negatives delaying treatment, or false positive causing unnecessary anxiety, or data leakage of medical records. In this, your control references could come from HIPAA, could come from ISO 42001 or ISO 13485. That mapping could be done. Do note the pattern here. So when you're creating your use case profile, having these fields helps you to map, to categorize, and to present these when asked for, either internally or externally or with a regulator. So when you give this type of information about your AI use cases, the conversation is much more fruitful, effective, and efficient. So this should give you an idea how you can build your own. Do note, this is an indicative. You can have much more refined, much more longer list of your profile. You can have much more higher field than this. The idea behind this is to provide you a very clear perspective as to how the 360-degree view can be created for your AI use cases. The next example, the public sector. This is use case is social benefit eligibility classifier. The objective is to automate screening of welfare applications to reduce backlogs and identify fraudulent claims. Model type could be logistic regression or rule-based hybrid systems. Data source are of course government census data, income tax record, tax filings, household demographics. Again it's high because there is societal impact, public trust and bias sensitivity is involved, so it would be high. Stakeholders are citizens, social workers, policy makers, advocacy group and so on. It could harm unfair exclusion of eligible citizens or privacy infringement or erosion of trust in government programs. So there is a deeper impact if things don't go the right way. Here you can map it out generally to the global regulations, either from EU, AI Act, or any other regulations which is local to your region. We'll take few more examples. The next is from retail and e-commerce. Its use case is about personalized product recommendation systems. The business is to increase user engagement and sales conversion by suggesting relevant product or in real time. Model type is collaborative filtering, neural recommendation systems, etc. Data source, of course, is customer browsing history, past purchases, clickstream data, or session metadata. Now, here you are impacted. Think through, this is you. Because if you have bought anything from any of the online websites, this is a case which fits that. The AI which is in play here would require to have these fields at least. Now, this is a medium risk. There are privacy concerns, hence medium would be at minimum used. Stakeholders, customers, marketing team, data protection officer, and so on and so forth. Potential harm, well, over profiling users might infringe into the privacy part of it. Here you will have GDPR Article 22 compliance, you need to be compliant with ISO 27701 and so on, or anything which is related to privacy controls. You look at your agreed framework that your organization has thought of or working already, you can map the privacy aspect to this use case. The next is the again fraud detection system from the BSF sector. The name, of course, here we have chosen as real-time fraud detection. The objective here is to detect and prevent fraudulent transactions while minimizing false positive. Data source is payment transaction data, device fingerprints, geolocation, customer behavior, and their profile. Because there is security and regulatory implications, this risk would be generally categorized as high. Stakeholders are, as we discussed earlier with the earlier business of online transaction or business, you'll have customer, fraud analysts, regulators, compliance related activity, and financial crime units. Harm, legitimate transactions could be blocked due to false positive or undetected frauds because of false negative or data misuse. In here you could have a mapping of your controls to ISO 27001 or your local regulators or SOC 2 controls and so on. I hope these fields helps you with your own AI use case. If you already have implemented AIs in your systems, in your organization, in your processes, while preparing your profiles, these are the fields which can help you build a very strong or at least a reasonably effective profile which can cut down a lot of time and chase. As I mentioned, there could be many more fields as such, but let's look at few of the. You have model owners and data owners, which defines accountability under a RASI. Next is having an human oversight mode, which describes how human judgments intervenes. You can have a life cycle stage. Purpose is for ideation, pilot, production, or retired stage. Next is external dependencies. You can define that. The purpose is for defining vendor models, APIs, or third-party data. And then you can, and I think this is important, audit evidence links, providing a direct hyperlink to assurance documentation. Now do note these are all documentation that would be required to be in place when either you want to review your own processes and your AIs, or you are presenting it to your internal audits or external regulators. Having this as a dossier helps you in that engagement, cuts down a lot of time and chase and any misinterpretation. So how to use this format? Well, in your AI risk register or inventory, this profile serves as the entry point for risk tiering, whether it's high, medium, or low. It helps as an entry point for traceabilities, which links to model card, risk logs, and audit governance, and cross frameworks compliance mapping. So, how your model aligns with NIST or ISO or EU Act or SR11. So, the whole story comes out in one shot. Key metrics, well, percentage of AI use cases inventorized. Through this, you should be able to get that. Ideally, near 100% if possible. Expectation would be to have all this in your inventory, in addition to your CMDB, but an important one and required in the current business. The next metrics would be percentage of use cases with documented harm scenarios. So when you build your profile, you would know what are the harm scenarios for each of the use cases. The expectation would be 100%, but at least have it greater than 90%. And you should be able to explain the gap if it is 10% missing, why and where, or maybe it is under progression. Because this is what will give clarity on how much control you are having on your AI systems. And the next one is percentages with complete data lineage record. This is something which is critical because if you don't know your lineage, you don't know how things are really moving. Again, ideally 100%, but if it's less than that, you would have a serious challenge because it would have a cascading effect on multiple processes. Do note, I've said 95%, the rest are 90, one is 90, and the inventory is 95%. But the idea should be, as you already have a clear idea about your inventory, this should generally be at, all of these should be generally at 100%. Yes, the harm scenario could be a challenge to document all. You would have some, a few, but all of the harm scenarios might be difficult when you are starting off. Rest of the wisdom can be applied, but there would be many harm scenarios which could be seen post implementation, as this is a new field. But that's where your life cycle comes into play. Phase 2, assessing. There are a few dimensions to assessment. Dimensions like biases, fairness, explainability, robustness, privacy, security, and compliance. These are all part of phase 2. The objective here is to quantify and prioritize the risk. The dimensions, let's go into them one step at a time. The measure for having a statistical parity difference of less than 0.1, say, is a measure that we do for biases and fairness dimension. We use CHAP futures contribution coverage for explainability. That's where we use it for explainability dashboards. For robustness, the typical measure would be having an accuracy change or maintaining it for less than 5%. The tools here are adversarial test tools. Similarly, for privacy, we have differential privacy to be maintained at less than 5 with no leakage of PII. For security, ideally it would be 0 critical vulnerabilities or less than 3 mediums. These are all examples. For compliance, the expectation is that we should have 100% policy mapping and no gaps from compliance perspective should be greater than 30 days. Let's try to understand in details. Let's go into each topic. For biases and fairness, the purpose of the assessment is to detect and quantify discrimination or unfair treatment in AI outcomes. So differences in positive outcome rates between groups is part of the statistical parity differences. So basically what it says here is the difference between groups, two set of groups, should not be negative. It should be identical if possible to. The second one is ratio of favorable outcome for protected versus unprotected groups. That's the DIR. For equal opportunity differences, gap in true positive rates between the group is the criteria that should be looked at. The difference should be looked at. The difference in error rate indicates your false positive or the negative parity. Qualitative checks of model assumptions and impact takes care of the human fairness review scores. These are used in credit scoring, loan approvals, hiring algorithms, or healthcare triage models. For explainability and transparency, the purpose here is to assess how well model decisions can be understood, could be justified, or could be traced back. In here, the typical measures would be like percentage of model features with interpretable influence value. Are we able to explain 90% of the model? Can we explain the ratio? Can we explain the logic? Can we measure the variance over time? See, when you implemented a project, it might have a high accuracy of say 100% theoretically. But as time changes over time, the variation might slightly change. So that's your stability index. Next is correlation between models and explanation prediction. Can you correlate the output against the what the original model was to be? Explainability. Next is documentation. Do you have a complete model card or data sheet? Example in this case would be customer facing AI decisions or regulatory reporting or audit readiness. That's explainability and transparency. The next is robustness and resilience. Here, the purpose of the assessment is to evaluate how stable and reliable the model is under stress or under in drift or under attack or during attack. Is it still stable and reliable? Can it be reliable during these conditions? Here, the measures would be, is there a drop in model performance on shifted data? That take care of the accuracy. Or number of successful perturbations that alter the predictions. This is about taking care of the adversarial attack or the sensitivity scores. Or percentage of anomalies detected correctly. Or model stability under extreme but plausible inputs. That's stress test. Example in this case would be fraud detection, autonomous systems, financial forecasting, or cyber security analytics. The next part of phase 2 would be the privacy and data protection aspect. The purpose of this assessment is to ensure data use complies with the privacy principles and regulations. Here, the metrics would be percentage of records with personally identifiable information in training and test sets. Takes care of the exposure from a PIS perspective. Next is level of noise added to protect individual identity. That is the differential privacy aspect. The next is probability that the anonymized data can be linked back to the individuals. Is that a possibility? That is the re-identification risk score. The next is percentage of data source with explicit consent or legal basis. That's the consent traceability coverage. And finally, adherence to DPDP, GDPR retention limit. That takes care of the data retention compliance score. In here, the cases or examples would be healthcare data sets, customer analytics, or marketing personalization. The next aspect is security and integrity. The purpose here is to assess protection of model, data, and infrastructure from manipulation or misuse. It is assessing. Here, the typical measures would be check the success rate of checksum or has verification, or number of exploitable vulnerabilities that were found, or percentage of privileged account with MFA or least privilege principles applied. Or it could also be percentage of deployed model with tamper detection. Or finally, existence and tested response plan, which covers the incident response readiness score. In this, the examples would be payment fraud AIs, recommendation on engines, or facial recognitions, or industrial AI. The final one is from compliance and accountability dimension perspective. The purpose of this assessment is to ensure AI governance aligns with your internal policies and external required standards or regulatory requirement, if you say. In here, the typical measures are percentage of, say, NIST or ISO Act controls requirement met, or percentage of controls with attached proof constituting logs, reviews, or reports, or clarity of responsible roles per control. Do you have that? Are the roles accountabilities clearly defined? Can you trace accountability? Or degree of conformity with internal AI charters. You have a charter which you would have defined in the early stages of it. How much of it is confirming? How much of your AI tools conform to this? Or finally, number of audits or external validation per year. Example here is BFSI regulatory reporting or insurance underwriting or risk analytics or HR automation. If you look at the risk scoring metrics, you have high, medium, low. This is a typical risk metrics, different combination. The rated ethical or systemic risk should be set a high impact, even if likelihood is uncertain. You might have something which is low, but the impact might be high when it is about ethical or systemic risk. The output, you have a quantified risk scores per model. You have an aggregated heat map for your AI portfolio, and you have an independent validation summary. So how these measures are used in practice? Well, each dimension produces a risk score. Typically, the format as shown. Bias and fairness would generally be, residual might be medium. Action in this case will retrain with balanced data sheet. So use this as a sample reference. This structured scorecard feeds into the next phase, which is phase 3, where you use mitigation steps, where remediation and continuous improvement plans are designed. Look at this sample screen. This is for the BFSI credit risk model. Say, you might have you have a threshold. If the thresholds are not met or in a zone, you might need to retrain your data set. You can do a review, or if it meets the standard, so be it. So then you are in line. This could be your scorecard, which should be ideally for per AI model that you have or tool that you have implemented. Coming on to alignment, many would have a query as to how does this align to frameworks. Here is the suggestions. For bias and fairness, you can use NIST AI RMF or EU Act. I've listed the annexures as well as sub clauses of it. For explainability, you have 42001 and so on. Robustness, you have the ISO 23894. For privacy, you have the GDPR or DPDP. You also have ISO 27701 linkage. For security, you have ISO 27001. You have mass related one. You have NIST SP 800 171. For compliance, you have ISO 42001. So if you see, 42001 plays a critical role in quite a few framework and mapping. It's a framework, it helps in mapping for many of the aspects when you touch the AI space. In the SS phase of AI risk, we measure not just performance, but trustworthiness. Each dimension, it could be fairness, explainability, robustness, privacy, security, compliance, acts like a diagnostic test for the health of your AI systems. Only by quantifying these aspects can you turn AI governance from a policy statement into a measurable assurance. Phase 3, mitigate. Well, the objective of this phase is to apply proportional controls and validate its effectiveness. We have about 6 control themes: data governance, model design, privacy by design, security controls, human in the loop, and policy and legal. In data governance, the typical action is to resample, relabel, or remove any proxy variables. In model design, simpler models are used for high stake use cases. That's a typical action that we should be taking. From privacy by design perspective, you need to apply federated learning. From security controls perspective, the typical action is to ensure prompt filters, RBACs in place, and there are rate limits for APIs. For human in the loop aspect, you need to have a confidence threshold routing mechanism or action taken. From a policy and legal perspective, in typical action is to have an impact assessment done. So there are few KPIs on this, wherein for data governance, the fairness gap should be not greater than 30%. Explainability score should be 85%. More than that, at least 85%. Privacy by design, well, there should not be any privacy incident per quarter. That's your performance indicator. And similarly and so forth, as shown in the screen. Let's look at it in detail. From data governance perspective, the typical mitigation action should be to establish an end-to-end data lineage tracking, the source, the pre-processing, and model input. Next is to define and enforce data quality thresholds, which constitute accuracy, completeness, timeliness. Next is to apply data labeling standards and documentation. Followed by need to monitor for data drift and concept drift continuously. And then introduce a dual sign-off for external data set ingestion to your model. In this, the KPIs could be data quality scores, drift detection frequency, or unapproved data source incidents. You can also have a percentage of data set with complete metadata or lineage target. In BFSI, these are used for loan underwriting or AI trained on transactions and credit bureau data. For healthcare, patient data curation for diagnostic image models. So you can use the mitigation action and enable the KPIs as shown. And the control theme is model design and development. Your mitigation actions could be to enforce model design documentation on the model cards, assumption, intended use, etc. You can apply fairness aware algorithms or conduct independent model validation or implement explainability testing or define model retraining and retirement criteria. In this theme, The KPIs could be model validation pass rates. You can set up a target based on your organization's appetite, or have a bias mitigation effectiveness post mitigations numbers, or you can have an explainability coverage ratio or model drift alert response times. In real world, in banking, this is used for credit scoring model validation against the SR11 controls, or in insurance, underwriting AI tested for explainability and stability. And the control theme is privacy by design. You can embed data minimization and anonymization in model pipeline. You can apply privacy enhancing technologies, differential privacy or federated learning. You can conduct privacy impact assessment before the model going live. Or you can implement automated consent tracking and withdrawal mechanism. Or you can apply role-based data access control and related masking. In here, the KPIs could be privacy incident rate or percentage of training data anonymized, or consent traceability coverage, or PIA completion rate for high-risk AI models. In real-world example, healthcare, you have AI diagnostics using patient imaging data under HIPAA or DPDP. In retail, you have personalization AI complying with GDPR consent norms. You can look at the scenario based on your industry and business and organization. For privacy by design, you can use these as a reference. What are typical mitigation action and KPIs? Do note these are indicative. You can fine tune it, change it, add a new one based on your requirement and your discussion with your management as your risk managers. Coming on to the security controls, the typical mitigation action in this would be implementing model and dataset access segregation, apply model versioning and cryptographic hashing for integrity check, or you can conduct adversarial robustness testing, or you can secure your ML pipelines and monitor for anomalies, or you can integrate AI risk into your enterprise SOC. These are typical mitigation actions. KPIs here could be adversarial test pass rates, defining that, or model integrity verification rates. That is something you can define, or MFA enforcement rate for privileged ML accounts, or mean time to detect an AI specific threats. These are some of the metrics that you can use to see how your security controls are performing. In fintechs, it is used for fraud detecting AI under ISO. In telecom, network optimization AI integrated with SOC threat modeling. So you have the mitigation action and you have the KPIs, which you can use based on your individual business and organization need. Coming on to the human in the loop control. The typical mitigation action is defining a clear threshold where human sight is mandatory. Example, high risk state. Second could be implementing override mechanism for critical decisions, or logging all human intervention for audit traceability, or training human reviewers on bias recognition and AI limitations, or establishing escalation workflows for flagged anomalies. These are your mitigation actions. From a metrics perspective, it could be percentage of AI decision reviewed by human for high risk tiers, or you can have a human override rates. What is the percentage there? Or what is the completion rate for reviewers training? Or audit trace completeness. In real world example is in BFSI it's loan rejection override by senior credit officers. Example. In public sector, welfare eligibility decisions reviewed by case managers. How many of this is there? That shows your KPIs are working, and if it is, then these are your mitigation actions and how it is performing. The next is policy and legal and compliance. The typical mitigation action would be maintaining an AI policy aligned to a framework, could be ISO 42001 or NIST or so on, or conducting quarterly AI risk committee reviews, or maintaining conformity assessment records, or conducting external audits or certification for high risk AIs, or maintaining regulatory watch to update controls per evolving standards. In this, the KPIs could be AI policy review frequency, framework alignment index, AI regulatory compliance violations, which should ideally be zero, but if not the case, then we can look at why, or independent assurance coverage. Real world example, BFSI is a board level AI governance policy under RBI and EU Act obligations. Or from a government, it's a high risk citizen data processing under AI ethics review. I hope this helps with understanding the phase 3 aspect of the life cycle. So, how does this fit into AI risk life cycle? Well, from access, which is phase 2, each risk dimensions, whether it is bias, privacy, security, etc., produces a scorecard of weakness or residual risk. That comes from phase 2. Then in phase 3, you map these weaknesses to control themes like data governance or human in the loop, or assign mitigation actions and define KPIs to monitor the effectiveness. Now, output of this phase 3 feeds into phase 4, which is continuous KPI tracking, moves on to the dashboard, and then having an internal and external audit assurance. That we'll discuss in part 4. Let's take a look at an example or BFSI loan decision through AI. So, the control theme here is data governance. You implement bias balanced data set with lineage tracking. You expect certain results, you have a target. Then you have independent model validation as part of the model design. Then you apply differential privacy. Then you conduct quarterly adversarial test. And then you need to require manual reviews for borderline credit scores. Or you have an AI risk governance reviewed quarterly by board. These are some of the things that can be implemented in BFSI. So how does this align? For data governance, you have the DPDP, you have the AI Act, you have ISO 23894. For model design, you have the NIST AI RMF or 42001. For privacy, you have GDPR and DPDP, which covers a very wide area. For security control, you have 27001 or NIST 80 and 853. For human in the loop, you have the EU AI Act recital or NIST AI RMF. For policy and legal, you have the ISO 42001 and related regulatory guidelines, could be MAS or RBI. So in the mitigate phase, AI risk management moves from knowing the risk to proving the fix. Each control theme becomes a mitigation lever, and each action becomes a control, and each KPI becomes evidence. The goal isn't perfection, it's measurable, explainable progresses towards trustworthy AI. Phase 4, monitor. The objective of phase 4 or the monitor phase is to ensure models stay safe and compliant in operations. There are 6 layers here: performance, drift, fairness, explainability, transparency, security, and abuse. And finally, you have incident response. In performance, you monitor accuracy. You compare it on the baseline. This has to be done real time or at least weekly. For drift, You monitor your input distribution and features importance. This should be daily or per batch. At fairness layer, you should look at the subgroup outcomes. This could be monthly. For explainability transparency aspect of the layer, you look at the changes in the top features required to be reviewed quarterly. For security and abuse, you look at, this is a place where you monitor prompt injection or model exfil attempts. This should be continuous. And for incident response, you monitor violations of SLOs or look at public complaints. This is as and when needed. For performance, the tooling is MLflow or evidently AI. For drift, it is data drift dashboards. For fairness, you have fairness KPIs. For explainability transparency, you have Sharp Delta reports. For security and abuse, you have SOC integration tooling. And for incident response, you have AI incident register. Now, what to watch and measure? Well, from a monitoring perspective, from a layer perspective, you have quite a few layers. One is performance monitoring, you have drift monitoring, fairness monitoring, explainability monitoring, you have transparency monitoring, you have security monitoring, or abuse or misuse monitoring, and incident response and escalation. Let's go through them one at a time. For performance monitoring, we need to monitor the model accuracy or precision recall or business KPI alignment. We need to monitor the prediction latency and throughput and service level adherence. Why it matters? Well, it ensures AI system continues to meet intended business and reliability outcome after deployment. That's why it matters. And drift monitoring. Why this is important? Well, it detects silent degradation when real world data changes faster than the retraining cadence. Here we monitor the data drift or the concept drift. Data drift is the statistical distance between training and the live input, whereas the concept drift is drop in the target label consistency. You have distribution shift or volume and velocity anomalies in incoming data streams. From fairness monitoring perspective, well, it helps prevent ethical or regulatory non-compliance due to evolving population biases. Here we monitor group-wise outcome parity per protected attributes. We look at false positive or negative parity trends, bias alerts, or impact analysis of retraining on fairness metrics. So that's fairness monitoring. From an explainability monitoring perspective, well, which helps ensure models reasoning remains interpretable and consistent even as the data evolves. In this, we monitor the stability of Sharp and Lime features over time, percentage of prediction with valid explanation generated, average explanation response time, correlation of explanation with user expectations. So that's explainability monitoring. Moving on to transparency monitoring. Well, this helps in maintaining accountability chain. This is where the paper meets the practice. Here we monitor the completeness of the model cards, data sheets, governance logs, frequency of documentation update, public or internal disclosure metrics, traceability links between model versions, which is policies and approvals. That's transparency monitoring. The next is the security monitoring. Security monitoring helps protect models and data from tampering or theft or any malicious exploitation. Here we monitor unauthorized access attempts, model integrity hash checks, adversarial attack detection, API anomaly detection, or vulnerability patch compliance status. So that's security monitoring. Next is abuse or misuse monitoring. Well, in this helps to detect human or third party misuse beyond the system design's intent. That's the importance of this. In this, we monitor misuse patterns, API outage outliers, terms of use violation detected by logs, or synthetic content fingerprinting to flag disinformation. The next is incident response and escalation, an important aspect of the monitoring layer. Well, this is important to measure resilience, how quickly the organization detects, contains, and learns from AI incidents. That's the importance of this aspect of the monitoring layer. Here we monitor time for detection, response, and closure, number and severity of AI related incidents per quarter, root cause classification. It could be data or model or infrastructure or human, or post incident retraining and remediation completion rate. These are used in banks' AI risk dashboard showing incidents that it's MTTR, or in healthcare provider executing retraining playbook post false alarm spikes. Now, if you think through this phase of monitoring, you have 6 various aspects here. Summarizing, we have performance monitoring, drift monitoring, fairness monitoring, explainability monitoring, transparency monitoring, security monitoring, abuse or misuse monitoring, and incident response and escalation monitoring. Operational integration view constitutes instrumentation, governance loop, and audit readiness. All models connected to observability pipelines constitute instrumentation, which includes Prometheus, MLflow, IZAR AI, or Y Labs. Example. The monthly AI review boards consumes these metrics, converting to issue mitigation tickets. That's your governance loop. And each metric auto-logged into assurance evidence repository under ISO 42001 is your audit readiness aspect of integration. Let's understand this a little deeper. What are the monitoring metrics? Drift alerts, retraining cycle, fairness gap changes, percentage of AI incidents resolved, and mean time for rollback. The output of this metrics is you have a live dashboards, you have quarterly AI risk postures, you have audit trails for regulatory inspections. So from a BFSI perspective, you will have a metrics and status as shown. You will need to have layers like performance, drift, fairness, explainability, transparency, security, abuse, or incident responses. So when you prepare your risk packs for AI related aspects, your snapshot should be something similar to this. Of course, you will have metrics, current values, and status based on your own individual organization needs and requirement and scope. The layers can also be subdivided based on the ease of reporting for you, or if you require more granular layers, you can have that defined and agreed. And here, the framework mapping should be like For performance, you have the NIST AI RMF. Fairness, you have the EU AI Act. For transparency, again, NIST AI. For security, ISO 27001, and incident response, you have 22301, and so on. Very similar to what we discussed earlier for other layers. What's the takeaway? Well, in mature AI risk programs, monitoring is not a dashboard of numbers, it's a living safety net. Each layer performance from performance to incident response forms a sensor in a distributed nervous system that keeps AI trustworthy, resilient, and compliant. Let's look at the next phase of govern. In govern, the objective is to close the loop through oversight, learning, and continuous improvement. There are 5 layers here, which constitutes the AI risk committee, independent validation, AI audit, training and awareness, and external disclosures. The function of AI risk committee is to approve policies, review exceptions, and set risk appetite. For independent validation, the function is to challenge the model and evidence. From AI audit perspective, the objective, the function is to verify the design and check for operating effectiveness. For training and awareness, the function is to review the ethics, explainability, and the incident playbooks. And from an external disclosure perspective, the requirement is to have a transparent report with energy footprints, fairness metrics, etc. Now let's try to break it further. Well, AI risk committee from a strategic oversight perspective, the first layer of governance. While there are overall there is different layers here, 5 to be specific. From a governance layer, you have AI risk committee layer, you have independent validation layer, you have an AI audit layer, you have training and awareness layer, and external disclosure layer, which we discussed all of this earlier, but now we go deeper. So from the first, the AI risk committee perspective, which is the providing the strategic oversight. The primary function is to set AI risk appetite, policy, and accountability structure. Next is to approve high risk AI use case before deployment and review quarterly risk metrics and interface with board risk and ethics committee. The next layer, it has its own cadence, the frequency and the format as shown, and real world examples. You can read through that. The next one is the independent validation, which is second line of defense. The primary function is to perform incident model validation, assess models design, data quality, and performance versus the policy, certify the fairness, robustness, explainability evidence before it goes live, and issue validation opinion with remediation action. The next is AI audit, which is your third line of assurance. The primary function is to provide independent assurance that controls operate effectively or operating effectively, review governance artifacts, test compliance with ISO 42001 or EU Act, and report directly to the audit committee. So that's your audit governance layer. The next is training and awareness, which is cultural embedding. Here, the primary function is to build enterprise-wide responsible AI mindset. Second, train AI developers on bias mitigation or privacy by design. Educate business owner on AI risk tiering and governance obligations. And finally, refresh the mandatory certification for AI practitioners. The fifth aspect here is external disclosures. Primary objective is providing transparency and accountability. The primary function is to disclose AI governance structure, risk mitigation measures, and incident summaries to regulators and public stakeholders. The next function is to publish model card, impact assessment for high risk systems, and respond to regulatory or public queries on AI ethics and compliance. These are annual governance report. That's the frequency. So, how does governance cadence connect? We have three lines or cycles: operation, tactical, and strategic. The purpose of operational is technical and ethical risk metrics. Output is a risk dashboard. Second line is for oversight and validation review. And third, the strategic one, is for assurance and external reporting. So how can you design your governance calendar? Well, you can have a quarter for AI risk committee, setting up risk appetite, training refresh cycle launches, and regulatory update reviews. You can have a quarter dedicated for independent validation for credit and fraud models, internal audit scoping, or AI control. You can have a quarter dedicated for thematic audit on biases and explainability. And you can have a quarterly board AI risk briefing. And you can have a quarter dedicated for annual AI governance report to regulators, external ISO 42001 surveillance audit, or awareness program renewal. But then you can design your own governance calendar, or you can align your calendar, the AI calendar, AI risk calendar, to your general risk calendars. The alignment is very similar to what we discussed earlier. You have NIST, you have ISO, you have EU Act aligning to each governance layer. So in summary, in the governance phase, cadence is control. AI risk committee decides, validation team verifies, auditors assure, trainers embed, and disclosures build trust. When each layer runs on its rhythm, weekly operations, quarterly oversight, and annual assurances, AI governance stops being reactive and becomes systemic. Now, if you look at from a different levels, at a reactive level, there is no inventory. Risks are found post an incident. There are no dashboards. There are audit findings and which are recurring. When you see this, your organization or the model is at a reactive level. When you see a characteristics where life cycles are defined but manually tracked, inventories are more or less about 90% there and has basic metrics, that's a structured level. When you see life cycle is embedded in the MLOps pipeline and you have automated risk code updates, you can say you have an integrated level. But when you have an early warning signals via drift and fairness analytics, and a drift alert is less than 2%, bias alert is resolved within 14 days, you can safely say you are at a predictive level. But when you have a cross organization learning set and public transparency in place with an annual RAI report published, you know your AI org is at an optimized level. So, as a senior management or a board, you can set this in your review and see where you currently stand. You can ask your AI heads or risk management head for AI space this question and see where does the characteristics fit in. At that point of time, you would know which level your organization is currently at. This is a summary map of NIST, ISO, EU Act, and SR 11 by 7, 11.7 for a different life cycle phase. Just to give you a perspective as to which one could help you at which level. Closing out, life cycle relates to heartbeats, which is continuous motion, not an annual audit. When you embed monitoring and alert directly into MLOps, you have survivability. This is something which you can do via automation. When dashboards and disclosures are your control evidence, you are building trust, part of transparency. Where every critical AI must retain override capacity, you are showing you have a final safeguard and human judgments are involved. AI risk management is not a compliance function. It's a living nervous system for responsible intelligence. So, concluding this part of the series, we have reached to the end of it. The next one would be tools, techniques, and guardrail aspect. Here, I'd like to thank you for the time that you have invested here. We have come to the end of AI risk management cycle. This is your host, Savit Vittal Salian. Taking your leave. We'll meet in the next video. Thank you.